Hello, my name is David Anderson, and I am a Specialist Solution Architect at Red Hat. Today, I will be installing OpenShift on Microsoft Azure Government. This video is intended for audiences who already have some familiarity with both OpenShift and Microsoft Azure. This video will demonstrate how to install OpenShift into an existing VNet that is disconnected or firewalled off from internet access. I will perform an installer provisioned infrastructure installation. I will be disabling the Cloud Credentials operator and set the Cloud Credential secrets manually. In this way, I can have a cloud-aware cluster that doesn't store and retain administrative credentials. As previously mentioned, I will perform this installation using an existing VNet in Azure Gov. This VNet consists of 3 subnets. The first subnet is a public subnet. This is where the RHEL 8 Bastion host is located. This host has internet access and will be our bridge for accessing the private subnets. There are 2 private subnets. One is for the control plane, and the other is for the compute plane of our cluster. There is another RHEL 8 host in the control plane. This VM will host our image repository mirror, and this will also be the server we will run the installation from. The private subnets are both behind a firewall, which blocks any routes to and from the internet. The only exception is that there are firewall rules that will allow requests to the Microsoft Azure and Microsoft Azure Government APIs. To perform this install, at least 2 service principal accounts need to be created. The first will be used for the installation and requires the roles of both contributor and user access administrator. The role for the other service principal account will only be contributor, and no other permissions and roles are granted to this account. For each account, we will need to know the subscription ID, tenant ID, client ID, and client secret. This information will be used later in the installation process. Also, we will need a copy of the pull secret from Red Hat in order to download the OpenShift images. Alright, now let's get started. Okay, in order to capture all the artifacts needed to install OpenShift, this guide will use a tool called OpenShift for Mir, which can be found on GitHub at Red Hat Gov OpenShift for Mir. In addition, the pull secret will need to be obtained from cloud.redhat.com. Alright, so let's go ahead and log into our Bastion host. Alright, in order to use the OpenShift for Mir tool, we will need to have podman installed. And if you don't have podman installed, simply do a sudo yum or sudo dnf install podman. Alright, next thing we're going to do is we're going to create a directory from which we're going to run the tool. So we're going to run the OpenShift for Mir tool, mapping this current directory to the app bundle directory. So to run this tool, we're going to run OpenShift Mir, giving it the bundle option. We're going to specify our OpenShift version. In this case, we'll do 4.6.3. We specify our target platform, which is Azure. Skip existing will, if we run this command multiple times, it will skip the download of existing images that have already been downloaded. And for this installation, we are also going to skip the operator catalogs. And now we need to paste in our pull secret. Okay, and now this tool is downloading all the necessary packages, images, including the OpenShift install binaries and OpenShift CLI binaries. And also the CoreOS image, along with all the images we need for OpenShift installation. Okay, we'll pause here and come back when this is completed. Okay, now that that is complete, we're going to exit out, and now we're going to package that into a tar. So if we look, we have directory 463 with the bin, catalogs, clients, release, and the rhcores directories. So we're going to tar that up. Okay, now that that's complete, we're going to copy it over to our registry host. Okay, now that that's copied over, we're going to log into our registry here. And we'll see that we have our file here. All right, we're going to go ahead and extract the file. Okay, now that the file has been extracted, we're going to go into our directory here. And the next thing we need to do is we need to create a SSL key insert in order to be able to host a temporary image repository. So So now that we have our domain key and our domain cert file, we also need to make sure that the firewall is open on port 5000. So in our case, port 5000 is already open. If not, you'll need to issue this firewall command and then reload the firewall. Okay, so now we're ready to we're going to use the OpenShift client, the OC tool, to host a web server that will act as our repository. So we use the image serve command. The directory path that we're going to provide it is our release directory under the 4.63, and then we give it our cert and key here. Okay. Now we can come over here and log into our Bastion host. And we can test to make sure that we can access the registry. Okay. So next step in this installation is we're going to create a service principal, and in order to create the service principal, we first need to identify what credentials are needed. And so to do this, we're going to going to go to the mirror products. Okay, so we're going to get the version information of the OpenShift install binary. And we're going to make note of this release image. So the release image is quay.io OpenShift release dev, OCP release, and then this is the SHA hash number for it. So from here, we're going to run the OC admin command, and we're going to extract the release information from this image, and we're specifically going to look for the credential request. For the cloud provider, Azure. Oh. Okay, so here we need to make note there are 3 credential request objects that get created during the install. These credential requests trigger the Cloud Credential Operator to create a service principal account for each of these services. So from here, we need to make note of the roles that are required and the name and namespace in which these service principal credentials are needed. So, for example, this one is needed in the installer cloud credential, is named installer cloud credentials, and the namespace will be OpenShift image registry, and the role is contributor. As we look, we're going to notice that each of these three all require the role of contributor. And so for the purpose of this install, I'm going to just create one service principal account that each of these three services will use. If you wish, you can create individual service principal accounts for each of these. But for this install, we're just going to do one. So now we need to create the service principal accounts. To do this, I'm going to use the Azure CLI commit tool. Okay. Now that I've logged in, I'm going to create a service principal account, and I'm going to name this this will be my administrator account that will be used for the installation. The administrator account needs to have the role of contributor and user access administrator. So we will first create it with the role of contributor. Okay. And from here, we're going to make note of the service principal, or sorry, the subscription, the tenant, the client or app ID, and its password. So next we will now assign the user access administrator role to this account. Okay. Now, I'm going to log back in. And this time we're going to create the service principal account that will be used by those three services that we saw previously. Okay. So again, we need to make note of the subscription, the tenant, the app ID, and the password. Okay. And now for the next step, we need to prepare the install config. So in order to do this, we also need some information to be able to set the content sources in order to use our locally hosted mirror. So to do this, we're going to use the ocadmin command. Okay, so we're going to do the release mirror. From the Quay.io OpenShift release dev OCP release 4.6.3 for the x86-64. And we'll give it so we're going to give it our registry mirror to mirror to, and we're only going to do a dry run. In other words, we're not going to actually mirror these files over, but by performing a dry run, we will be able to get some information that we will need to add to our install config.yaml file. Okay. So the part that we want to make note of is first in the install config.yaml, we want to add this to the file. So the image content sources, specifying our registry as the mirror for the Quay.io sources. The next part to do upgrades using this mirror, you'll also want to create an image content source policy with this as the spec for it. For this demo, we will only be doing the install. We will not be doing any updates. So save that off. Okay. And now we're going to log into the registry. Okay, so first thing we're going to do is we're going to create a directory to do the install from. And I have an install config template here that we're going to copy. And now we're going to edit that file. So in the install config template, we've defined our base domain and our compute and control plane information regarding the disk size and the type of VMs and the number of replicas. So this cluster will install 3 master VMs and 4 compute or worker VMs. In addition, so we have our base domain and then the name of our cluster and then the CIDR for our cluster network. This has to be a unique CIDR that will not conflict with any existing CIDRs in your network. These next 2 CIDRs are for the subnets that we have defined in our VNet. So one of these is for the master control plane, the other is for the compute control plane. And then here we define our Azure platform specific information, such as the domain resource group name, the cloud name, the compute subnet. So this DBA Sparta SN2 corresponds to the CIDR 10.1.2 up here. And then our control plane subnet, Sparta SN1, corresponds to the 10.1.1 above. We have our network resource group name. And then since we are doing a private disconnected cluster, our outbound type needs to be set to user defined routing. We specify our region, so US Gov Texas or US Gov Virginia are supported. And then the name of our existing VNet. So in this case, it's DBA Sparta VNet. Again, since we're doing a private disconnected cluster, we need to set publish to internal. Here we define a pull secret for our internal registry mirror. In this case, this is a simple mirror, so no auth is needed. And now we need to provide the additional trust bundle, which will be the domain cert that we created. So I'm going to go ahead and insert that. And then our image content sources. Is the mirror information that we obtained from the dry run. And then optionally, you can include an SSH key. This SSH key will allow you to log in via SSH to the worker and master VMs if needed for typically for troubleshooting purposes only. So, all right, we're going to save this file. Okay, so now that we've saved that file, we need to now generate our manifests. So first, before we do that, I'm going to demonstrate that we are disconnected. So we are unable to access the redhat.com or google.com. Just to so over here we can, but from our registry host we are unable to. So we are in a disconnected environment. So now we're going to run the OpenShift install, but we're not going to perform the install just yet. We're going to create manifest files. Okay. Okay, forgot to clear out some old credentials here, so okay. Let's run that again. Okay, so the first time we run this, it's going to prompt us for our Azure credentials. So we need to provide it the subscription ID, our tenant ID, our service principal client ID, also known as the app ID, and then our password. Okay. Now that that's done, it will have created a file under the Azure.Azure directory called OS Service Principal. In that file, you'll find the subscription ID, tenant ID, and client ID that we provided. And so anytime we run this OpenShift install moving forward, it will use the OS Service Principal JSON file rather than prompting us again. All right. So now that we've created our manifest, as I stated up front, the purpose of this install is to do manually created IAM or service principal accounts, so that we do not have to store the administrative level account in the cluster. So in order to do that, we need to disable the cloud credential operator. And to do that, we're going to create a file. We'll call it ccoconfigmap.yaml. And in this file, we're going to create a config map in the cloud credential operator namespace that will set the cloud credential operator to disabled. Okay, so now we need to copy that file to our manifest directory. Okay. The next thing we need to do is we need to remove the cloud credentials secret that was created. That was the secret that would have stored the credentials for our admin service principal account. And so the next thing we needed to do is we need to look at the OpenShift install state. And we're going to look for the cluster ID. And we're going to make note of the infrastructure ID value. Okay, we saved that off. Now we need to create, since we're not going to use the cloud credential operators to create the secret credential accounts for us, we're going to do this manually. So we now need to create 3 files. So we're going to create an Azure Cloud Credentials, Installer Cloud Credentials. These 3 files correspond to the cloud credential requests that we looked at earlier. And in these files, we're going to create a secret. And we're going to set the resource prefix and we're going to provide the name namespace. And we need to provide the client ID. And the password. Oh, wrong client. Okay. This is the client ID for our non-admin account and its password. Okay. Let's save that. We're going to go to the next file. And providing it the same information, but we need to change the name. And the namespace. Okay. And then do that for the last file. Okay. Now, if we were using 3 different service principal accounts, obviously the client ID and client secret would need to be set for each unique service principal. Okay, now I copy these files. Into the OpenShift installation directory under the OpenShift path. So just a tip, all these files that we've created manually, including the install config YAML, it's good to keep a copy separate from the install directory, because the files in the install directory will be altered and deleted as the installation completes. So it's a good idea to hang on to these files just in case you need to rerun the install. Okay, so now that we have those files in place, we've set the cloud credential operator to disabled, we've removed the admin credentials. Now we're going to run the install. And we're going to, okay. And I will pause here and we'll come back once the install is complete. Okay, our installation has completed successfully, and we've been given our console and our kubeadmin and password. We see that the install took a total of 39 minutes and a few seconds to complete. So to test this out, we're going to export out our kube config. And we're going to execute an OC. So as you see, we have our 3 master nodes and our 4 worker nodes as defined in our install config YAML. And to test the console, since this is a cluster that's private on a disconnected VPN, if we attempt to access that server, we're not able to access it unless we connect to our virtual private network. So to do that, we're going to use S-shuttle. To connect to our private network, and we need to give it our bastion IP. Okay, and now we're connected, and now we should be able to hit the console. Make sure I connect it to the right one. Oh. Sorry. Okay, let's try that again. Okay. And there we have it. We have our cluster is successfully installed and up and running and ready for use. Thank you for watching, and have a great day.